Hi, this is Dr. Collins Jones. Welcome to segment 4 of my video series on measurement, significant figures, and basic data analysis. In this segment, we will have an introduction to uncertainty in measurements and significant figures. Let's talk about measuring devices and uncertainty. And the measuring devices we are considering here are the basic ones that you would encounter in any chemistry, biology, or biotechnology laboratory. It would include things like an electronic balance, a spectrophotometer, a pH meter, a conductivity meter, volumetric glassware like a graduated cylinder, things like that, all right, and timers, of course. So the idea of uncertainty is this. In any measured quantity, we assume that the final digit is uncertain by at least 1 unit, right? So if we look at the volumetric measurement of 9.5 mils, the last digit, the 5, is assumed to be uncertain by 1 unit. So what that means is that while we observed 9.5 mils, it could actually be 9.4. So if we come back and make a second observation, maybe on the second observation, instead of seeing 9.5, we now see 9.4 or 9.6, right? So we're uncertain by 1 unit. So we can express this uncertainty as 9.5 plus or minus 0.1 mils. And what that means is this is 9.5 plus 0.1 to give us 9.6 mils. We have 9.5 mils, what we actually observed, or 9.5 minus 0.1 to give us 9.4 mils, which also would be an acceptable observation. That's the range that we have due to the uncertainty of the final digit being measured. If we consider a weight, 2.987 kilograms, the 7 is considered to be uncertain by at least 1 unit, meaning that the measurement may actually be 2.988 kilograms, 2.987 kilograms, or 2.986 kilograms. And again, we can express this as 2.987 plus or minus 0.001 kilograms. Now, in practice, if it's only uncertain by 1 unit, then that we know that that's assumed, that's a given, so we don't actually write the plus or minus 0.001 kilograms or 0.1 mils. We know that it's there, so we don't waste the time and effort and space to write that out, okay? We will address shortly what happens if it's uncertain by more than 1 unit, all right? But for right now, I just want to make sure that we're getting introduced to this idea of plus or minus, and that our measurement could actually be 1 unit higher or 1 unit lower than what we are actually observing. So let me try to illustrate how that can come about. You know, how do we get that level of uncertainty? To do that, I'm going to illustrate a measurement of temperature. So we have here a thermometer, and I'd like you to please keep your attention on the temperature scale on the left-hand side. That is the scale that is in degrees centigrade. And so you can see, you know, this is every 10 degrees is subdivided by 1 unit, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth, right? This thermometer is an alcohol thermometer. So at the top of the liquid, at the surface of the liquid, it is flat, okay? So we're just going to assume that this is a flat liquid at the top, and where the liquid rises up according to the temperature. So what we want to do is see where the top of this liquid corresponds on the actual temperature scale, and then we will make a measurement. Okay, so let's look at this. If I look at this scale and I look at 20 right here, right? So this is where we're focusing on again, right? If I look at 21 degrees centigrade, I see that 21 is actually below the top of the liquid. So we know that the temperature has to be higher than 21 degrees. So I go up to the next calibration line. Okay, I go up to the next calibration line, 22 degrees, and I see that the top of the liquid is slightly below 22 degrees. So I know the temperature lies somewhere between 21 degrees centigrade and 22 degrees centigrade. So what I now have to do is mentally, between 21 and 22 degrees centigrade, I have to imagine 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 little calibration lines. They're not there, but in my mind I have to make this estimate. So if I make the first estimate, I look at this line and I go, gee, to me that looks like 21.8 degrees centigrade. Okay? So maybe I call a colleague over and say, can you take a look at this? Tell me what you think the temperature is. And that person may estimate it to be 21.9 degrees, right? The temperature hasn't changed, but the observer is observing this just a little differently. And we're going to assume that they're looking at this head on and everything is correct, but it's just the way they're estimating it. I call over a third colleague. They look at it and go, nah, that really looks more like 21.7 degrees to me, right? So as I look at that, I go, gosh, I actually have a range now. And that range turns out to be 21.8 plus or minus 0.1 degrees C. And that's how we get that uncertainty in the estimate of the measurement. Now, this was due to the observer. But it turns out that electronic readings, right, balances, pH meters, and so forth, there's also uncertainty in that last digit. And how that uncertainty comes about, we will explain in a subsequent segment. But for now, let's just focus on identifying the uncertain digit and really understanding this concept of plus or minus. So I've given you 3 measurements here. What is the uncertain digit in each of the following measurements? So in 34.1 mils, right? And this is easy. It's the last digit, the last number in our measurement is the uncertain number. So 1 is uncertain, right? In 34.1 mils, 1 is the last digit, it's the last number, so it is uncertain. In 0.0559, 9 is the last digit, so the 9 is uncertain. And in 500.0 milligrams, the 0 is the last digit, so it is uncertain, okay? Just to make sure that we understand this concept of plus or minus, if we make more than one measurement, so, in the previous slide, I had 3 observers come in there. Suppose I had 10 observers come in, we made 10 measurements, right? The range of differences might go beyond 0.1 degrees centigrade, okay? And so if we do repeated measurements, these are called replicates of the same thing, then what we do is we calculate something called the standard deviation, and the standard deviation tells us the range. And we'll go into this in more detail in another segment. But assume right now that we've made repeated measurements of this particular weight, right? And we end up with 34.56 plus or minus 0.04 grams. So what does this mean in terms of the range of acceptable possible readings? So 34.56 plus or minus 0.4. What does that really mean? Well, it means that we have a range of 34.56 plus 0.04 grams to give us 34.6 grams, okay? And we have 34.56 minus 0.04 grams to give us 34.52 grams. So this is sort of the upper and lower limits of our measuring range. We don't expect to get readings, we don't expect to get weights outside of this range, but anything within it is acceptable. So let's just look at that, right? The acceptable range from 34.52 to 34.60 is all these numbers, right? Everything in between. Any one of those numbers, 34.53, 34.58, 34.57, all of these measurements would be considered correct because they're within the range of our deviation. So hopefully that helps you to understand what we mean when we have plus or minus in a measurement, okay? All right, let's do a quick review here, right? So here we have a timer, and I'm asking you some questions here, right? What are the units associated with each of the numbers on this timer? Which measurements on this timer are exact? Which measurements are estimates? What are the uncertain digits in the measurements that are estimates. All right. So I'm going to do my normal count to 3, maybe a little more, and then I'm going to advance the slide. But in the meantime, I'm hoping that you will write down on a piece of paper what you think the answers are. Okay, here we go. The units. We have 11 hours, 56 minutes, and 37 seconds. So we have hours, minutes, seconds, units of time. We have March 13th, the third month, and it's the 15th day of the month. The temperature, which may have been a little hard to see there, but the temperature is 71.1 degrees Fahrenheit. The exact measurements are the month and the day of the month, right? So if we want a fraction of a day, we express that in terms of the actual time. But for the whole month of March, it's always the third month, and it's the 15th day from midnight until 11:59 that day. Okay, so I'm going to consider the day of the month and the month of the year to be an exact measurement. The estimated measurements are the time, 11 hours, 56 minutes, 37 seconds, because the timer or the clock is a measuring device calibrated against a standard unit of time. Remember our international system of units. Similarly, the temperature, 71.1 degrees Fahrenheit, that thermometer is calibrated against a standard thermometer. Okay? So, the uncertain digit, I will circle this in each measurement. Right? So the 7, the last digit, is uncertain. That, 07 seconds, that is what's uncertain. And the 1, right, the 0.1 is uncertain in our temperature reading. Okay, so now let's really try this, okay? So here we have a worm, the one we kind of started with earlier. We're trying to measure the length of the worm. This could be a biology experiment to see if the effect of the environment changes the length of worms. So we may measure worms in 2 different environments and compare the lengths of those worms and see if there's any difference. That's really all about statistics, but we have to make each individual measurement first. All right. So what we're asking here is what unit is being measured, what is the complete measurement, and from this measurement, what is the uncertain or estimated digit. So we want you to write that down and also circle it. Okay, so we have a ruler here, and I've kind of helped you to make where the estimate would be in this reading. So just go with this, if you will, for the purposes of this example. So I'm calling this roughly 5.82 centimeters. Okay, so what's being measured? Length in centimeters. The complete measurement is 5.82 centimeters. A number, right? A magnitude and a unit. Okay, a number plus a unit. The uncertain digit, well, it's still the last digit. So the uncertain digit is the 2. All right, and that's all there is to this. Pretty easy, right? Okay, so here we have a balance. Same thing. What unit is being measured? What is the complete measurement? And what is the uncertain or estimated digit? Okay, so the unit being measured is grams. We're obtaining a weight. The complete measurement is 85.72 grams, right? The number plus the unit. The uncertain digit is the last digit, right? So that's the 2. So again, our uncertain digit is a 2. All right. Even though it's electronic balance, even though the display looks stable, the last digit displayed is the uncertain digit. Okay. For this weight, what is being measured? What is the complete measurement? What is the uncertain or estimated digit? Okay. So again, the unit being measured is grams. This is a weight. Okay. The complete measurement is 20.96 grams. We've just read that off the display. Okay. And again, it's a number, 20.96 plus the unit, grams. Once again, the uncertain digit is the last digit displayed, the 6. Okay. So hopefully that was pretty straightforward to everybody. You guys all got that. Let's try one more. All right. So here we're measuring a temperature. So we have a thermometer. The unit being measured is degrees centigrade, a temperature. What is the complete measurement? 59.6 degrees centigrade. Remember, whenever we record, whenever we document a measurement, it has to be the number plus the unit. We always need to include the number plus the unit. What's the uncertain digit? Again, it's the last digit on the display. In this case, the 6. So our uncertain digit is 6. Significant figures. So now you get an idea here, right? So some digits are certain, some digits are not certain. So when we talk about significant figures are those digits in a measured value, right, that include all the certain digits plus the final estimated or uncertain digit. So it's no different than what we've been doing. So if we make a measurement, a weight of 54.189 grams, all these digits are recorded as part of the measurement. The certain digits are the 54.18. And the uncertain digit, right, which is uncertain by at least 1 unit, is the last digit, is the 9. Okay, so this is pretty easy. To determine the number of significant figures in a measurement, you just count the number of digits. 1, 2, 3, 4, 5. So this particular measurement has 5 significant figures. And again, the last digit, the 9, is uncertain, but it's still significant. It still counts because we saw it when we made the measurement. Okay? It was there. We could observe it. Now let's look at how the number of significant figures can depend on the measuring device. So this is one of the balances in our lab, and I put some different items on the balance to give me different weights. All right, and so if we look at the first panel on the left, we look at that weighing. I've just helped to point out where the decimal point is. All right, so there's our decimal point. Our weight, our measurement, is 1.370 grams. Okay, so the number of significant figures, we just count the number of digits on the display. 1, 2, 3, 4. So there are 4 significant digits. The last digit is our uncertain digit. Now, these are new balances that we just got about 6 months ago. And what's interesting here is you may have noticed the last digit is bracketed. So the balance, the software in the balance is actually telling us this is the uncertain digit. But if we didn't have this software, the last digit would be the uncertain digit. Okay? So let's go to the next weight. Put a little more on the balance. Decimal point is shifted a little bit. So our measurement now is 28.858 grams. Okay? The number of significant figures, 1, 2, 3, 4, 5. So we have a higher weight. More digits are displayed. It's the same balance, but we have more digits displayed because the weight increased. So the number of significant figures is 5. Again, the last digit is the uncertain digit, the 8. Okay? And then finally, I put even more weight on the balance. Okay? And so now our measurement is 228.232 grams. 228.232 grams. So with even more weight, the number of significant figures increases to 1, 2, 3, 4, 5, 6 significant figures. And again, the last digit is uncertain, so the 2 is our uncertain digit. So hopefully that makes sense. That's why even though we're using the same measuring device, depends on the amount, the actual physical amount that we are measuring. But we just read that on the scale, and whatever we read, the total number of digits are the number of significant figures, and in those significant figures, the last digit is the uncertain digit. So let's wind this up. Let's end this segment with just this quick sort of practice problems, okay? So I've given you a measurement, and I'm going to ask you for the number of significant figures to identify the uncertain digit, and then just sort of tie this into other things. What's the most likely measuring device we used, the name of the measuring device we used to make this measurement? Okay, so again, I'm going to pause right here, count to 3 or 5, and try to see if you can write this down on a piece of paper And then once you've completed this little exercise, come back on and see how you did. Okay, I'm back. Let's see how you did. Number of significant figures, 17.052 kilograms. 5, right? Uncertain digit, the last digit, 2. This is a weight, it's a mass, so probably we used a balance to weigh this. 15.0 psi, pounds per square inch. All right, there's 3 significant figures here. The 0 is uncertain, and this looks like a pressure to me, so we probably used a pressure gauge to measure this. 16.84 degrees centigrade, 4 significant figures. The last digit in the measurement, the uncertain digit, is 4, and since it's a temperature, we used a thermometer. 100.0 centimeters. 4 significant figures again. The last digit is 0, so the uncertain digit is a 0, and we probably used a ruler or a meter stick to make this measurement. 0.0602 grams. All right. The zeros, I haven't given you the rules yet, so just trying to see if you remember this, right? Zeros in front of the number are not significant. So this only has 3 significant figures, 602. And the 2, the last digit, is the uncertain digit. And again, we probably used a balance. 8.25 minutes, 3 significant figures, the uncertain digit, 5. And we used a timer or a clock. 1.602067 grams. This has 7 significant figures. The last digit is what? A 7. So the 7 is the uncertain digit. And again, we used a balance. And then finally, 35.000189. Guess what? There are no significant figures. There's not an uncertain digit because this is not a measurement. There's no unit there. So with no unit, it's not a measurement. It's just a number. Okay. So always keep this in mind when you're recording or documenting data. Did you notice that we have not covered measurements involving liquids? We're going to cover liquid measurements in segment 5, the next segment. But that's the end of segment 4.